Hi there. Last year I had a particularly bright A-level further maths student. He kept asking me challenging questions, which I'm quite into. But this particular one was a bit of a head scratcher. So he asked me what the square root of I was. What is the square root of I? Well, we know the square root of -1 is by definition I, but the square root of I is a little bit more tricky. So I decided to give it a go by creating a complex number z, yet to be determined, setting it equal to what we're after. Okay, and obviously z I'm going to write as a plus bi, complex, with the real and imaginary parts respectively, and set that equal to root I, which is what we want. And I thought, well, logically, if I square both sides, I'm going to square this and obviously square that to get I, and set the real and imaginary parts together and see what happens. So multiplying this out, I get a squared plus 2abi plus b squared I squared. That's equal to y, and obviously by definition I squared is -1, so we can get rid of that. Okay, so we seem to be getting somewhere. I'm going to collect my real parts together, so a squared minus b squared plus 2abi equals I. Okay, so immediately you can probably see that the right hand side has no real component, and the left hand side has a real component in terms of a squared and b squared. So I know that a squared minus b squared must equal 0 because it's 0 on this side. Now, the only way for that to be true is if a equals b. So we've found something about this mystical number, but also we know here the imaginary part 2ab, the coefficient of I, must be equal to 1. So we can say that AB is equal to a half. And because we know A and B are equal, I'm going to set B equal to A, and I've got A squared equals a half. So A is equal to root 1, which is 1 over root 2, or root 2 upon 2. Okay, actually it's plus or minus that, because obviously there's always two solutions. So we seem to have found something. Okay, so I'm going to plug in my values of A and B, which are the same. So A is equal to, so we know Z is equal to root 2 upon 2 plus or minus, I'm just going to do the positive value, root 2 upon 2i. So is it going to work? Let's find out. I'm going to square this, okay? So it's going to be root 2 upon 2 plus root 2 upon 2i all squared. And if we multiply that out, we get root 2 upon 2 squared, which is a half, plus root 2 upon root 2 times root 2 upon root 2i doubled, which actually is nicely just equal to I, and then root 2 upon root 2 squared multiplied by I squared, which becomes negative a half, cancelling the real parts out, so we get the I we're after. So it seems the square root of I is actually root 2 upon 2 plus root 2 upon 2i. Okay, I hope that made sense. Anyway, I enjoyed that.